In this question, the signal flow graph is given to us and we have to determine the transfer function of the system C of S by R of S. Okay. Now we are going to make use of the Mason's gain formula, according to which the transfer function C of S by R of S is equal to sigma Pk del k, where k is the number of forward paths, divided by 1 minus sum of individual loop gains L1 plus L2 plus so on, okay, plus product of the gain product of the gain of loops which are not touching. Okay, so it is L1 L2 if L1 and L2 are not touching and so on. Okay, now if we look at this figure, the signal flow graph, we see that there are actually two forward paths, one which starts from R of S and then comes here and then comes right to C of S. Okay, this is one of the forward path, and then if you see, there is also a forward path which goes to the right extreme and then comes back through the feedback. Okay, if you are considering that the second forward path is also a valid forward path, then it is wrong, because in the second forward path we are traversing through this node twice. Okay, so we should not be considering that as a forward path. So we are having only one forward path, which is this. Okay, now k is equal to 1 because we have only one forward path. So the corresponding forward path gain P1 is equal to 1. Okay, we have 1 into 1 is equal to 1. Now we have to determine del 1. Del 1 is the determinant of the loop that is not touching our first forward path or the only forward path in this particular case. Okay, now if I see there is a loop here, but it does touch the first forward path, it is touching here, and I am having two more loops, one is here and there is another loop here, and these two loops are not touching the first forward path. So I have to consider these loops when I am determining del 1. So del 1 is equal to 1 minus, the procedure for determining del and del k are same. Actually del we are determining for the entire system, so we have to consider all the loops. For del k we have to consider only those loops which are not touching the forward path. Okay, the formula everything is the same. So 1 minus 3 by s. Okay, it is the loop gain of or the gain of this inner loop, and then I have to consider this outer loop also. It is minus 24 by s. Okay, so del is equal to, okay, this is del 1. Okay, now we have to find del, and for finding del now we have to consider this loop as well. Okay, it is 1 minus, okay, minus 2 by s, gain of this smaller loop, and then minus 3 by s, this loop, and then there is one more loop, 6 into 1 by s into minus 4, so minus 24 by s plus 6 by s square. Why? Because this smaller loop and then this loop are not touching, so minus 2 by s into minus 3 by s I will get as 6 by s square. So del is equal to 1 plus 29 by s plus 6 by s square. So when I substitute that in C of s by R of s, then I will get the transfer function of the system as s into s plus 27 divided by s square plus 29s plus 6. Okay, so this is the transfer function of the system.